Hello, and welcome to my channel. In this video, I am going to cover Windows storage spaces on Windows 11 to provide native high-performance storage with data resiliency and online expandability. What is Windows storage spaces? I'll let Microsoft Jenny give a brief explanation.
Storage spaces can help protect your data from drive failures. It's a technology in Windows and Windows Server and is conceptually similar to redundant array of independent disks, RAID, implemented in software. These drives typically store extra copies of your data, so if one of your drives fails, you still have an intact copy of your data. If you run low on capacity, just add more drives to the storage pool.
Thank you, Jenny. The client for this demonstration is a Hyper-V virtual machine running Windows 11 Enterprise 22H2 with 32 gigs of RAM, 8 processing cores, 8 4-terabyte drives, and a 512 gigabyte drive for the operating system. Storage spaces for Windows 11 is functionally identical to storage spaces on Windows Server 2022. Please see my video, Storage Spaces, Windows Server 2022 21H2, for a more detailed description. We'll cover installation and configuration, disk failure, repair and recovery from disk failure, expansion of capacity, and creating a storage pool via PowerShell commands. Click the Start flag, followed by Settings. At the System page, click on Storage, Advanced Storage Settings, Storage Spaces. Click Add. Provide a descriptive name for the pool. You can select all drives or a combination. Here, we're going to select all by checking the Available Disk checkbox. Click Create. Assign a meaningful name to your storage space. The default size will be set to the total combined capacity of the selected drives. In this instance, we'll initially allocate 50% of the aggregate capacity as we plan to implement a two-way mirror for resiliency. We'll expand the storage pool later by integrating higher capacity drives. For the resiliency, we have 5 options: simple, two-way mirror, three-way mirror, parity, and dual parity. We'll keep a two-way mirror for the best balance of performance and resiliency. With 8 drives, a two-way mirror can actually sustain 2 simultaneous disk failures. But please never let it get that far. Click Create. Now we have to create a volume. In this case, we'll assign the drive letter E and leave the file system as NTFS, even though REFS is available and desired in certain situations. Click Advanced. We can also mount to an empty NTFS folder, allowing for a single drive letter or volume namespace akin to Linux practices. We'll implement both here. Leave allocation unit size at its default setting. Click Format. Close Settings. Open Windows Explorer and select this PC. Notice the 16 terabyte volume. Copy some data to this volume. Likewise, open C drive and notice the mounted folder. Open the mounted folder to confirm the data is there. Now, we're going to simulate a drive failure. Open Storage Spaces. Open the storage pool and notice the status reads, Warning, degraded. Looking at the physical drives, Note the absence of one drive, signaling the degraded state of the storage pool. Despite the degraded status due to a missing or faulty drive, the storage pool maintains data integrity, remaining both readable and writable. To repair, we have to replace the faulty drive, add it to the pool, and then retire the old drive. The faulty disk has been replaced. Open storage spaces. At physical disks, click Add a disk. The new replacement disk is showing as being available to be added to the pool. Select the disk and click Add. Locate the missing faulty disk and click Properties. Click Prepare for removal. The duration of this step depends on the amount of data in the volume. Please be patient. When the process completes, click Remove. The storage pool is again healthy and happy. The great thing about storage pools is that we can easily increase capacity by replacing the existing disks with new ones of higher capacity or installing additional disks. This is where software-defined resilient storage pools differ from RAID arrays. Here, we're going to replace several of the 4 terabyte drives with 8 terabyte models and increase the volume size. Warning: when replacing existing drives, do each one separately. Doing 2 or more at the same time could irrevocably break the pool, resulting in data loss. The procedures are similar to those for replacing a failed disk. Open storage spaces. You may see a degraded status. That is okay. At physical disks, click Add a disk. The new replacement disk is showing as being available to be added to the pool. Select the disk and click Add. Retire and remove the old missing drive. Do the same for the other drives to be upgraded. Once the drives have been upgraded, click Properties next to the storage space and click Extend. Since we've upgraded all 8 4 terabyte drives with 8 8 terabyte drives, we'll increase the space and volume to 32 terabytes. Likewise, you can extend the storage space and volume following each disk replacement, or you can extend prior to the drive replacements. Open Windows Explorer and select this PC. The 32 terabyte volume is shown along with the data intact. The mounted folder reflects the same. As with everything else, you can also create a storage pool via PowerShell. The commands here are valid for Windows Server 2016, 2019, 2022, Windows 10, and Windows 11. Open an administrative PowerShell shell. Although I have the new cross-platform PowerShell 7 installed, I'm going to use the Windows PowerShell that ships with the operating system. To get an inventory of eligible drives, type
Get physical disk can pool $true.
For this example, we're going to pool the 8 12 terabyte drives. First, let's define some variables to make the commands easier and to reduce the likelihood of introducing errors. Create the storage pool. Create a thin provision storage space virtual disk with two-way mirror resiliency. To ensure we're working with the right drive, type
Get disk serial number star.
The partition style should be raw. Initialize the disk and create a new volume. In this example, we're going to format the volume using REFS and assign the drive letter G. If desired, mount the volume to an empty folder to provide a single volume namespace. Open storage spaces to see the new pool. Expand for details. Open Windows Explorer to see the drive. Any drive to be added to a storage pool must be an empty primordial drive. If a drive has any partitions, volumes, or data, it cannot be used as a storage pool drive. That is, until we prepare it. Warning! Take extreme care with the below steps to avoid inadvertent data loss. To prepare a previously used disk, open an administrative PowerShell or command prompt and type disk part. Type list disk. Find the disk you want to prepare and type select disk and specify the number of the disk to be prepared. Type list disk again to verify the correct disk was selected. Type clean. Type offline disk. Type exit to exit the disk part utility. Reboot. The drive can now be added to a new or existing storage pool. Likewise, you can use PowerShell to accomplish the same. The same warning applies here as with using disk part. In an administrative PowerShell, type get-disk to find the disk number X to be prepared. Using get physical disk could lead to confusion as to which drive to select when most of the drives are the same. Type clear-disk number X remove data remove OEM. Type set-disk number X is offline $true. Reboot. The drive can now be added to a new or existing storage pool. We have covered the initial configuration of Windows storage spaces, the identification of and recovery from a drive failure, and the expansion and increase of storage pool capacity in Windows 11. These steps and procedures are also valid for Windows 10. However, they differ slightly. And please see Storage Spaces, Windows Server 2022-21H2. I hope you enjoyed this video, learned something new, and found it useful. If you have any feedback, corrections, or suggestions, please let me know in the comments below. Please like, subscribe, and pass it on to others. And I thank you for watching.